So yes, I'm going to be talking a bit about, mainly about the droughts work we've been doing in the UK. I apologise to people who looked at the abstract where I mentioned about the UK and beyond. I was going to talk a bit about international work, but it was just too much. So I'm just going to focus a bit on the UK. And really with a theme of looking at the work we've been doing on research, but also crucially how we've been trying to translate that work into decision making and drought management, and working with all sorts of users and stakeholders to understand their needs around droughts. So that's what I'm going to be talking about. And I'd just like to start off with a bit of an introduction to CEH. As Sergio has said, it's very similar in many respects to the Institute here in terms of the work that we do. This is just from our website, one of these things that we like to put out the organisation in numbers, much of which is perhaps not that it's difficult to engage with. But the key point is that there's 4 sites around the UK. I work here, where Sergio's been to visit, in Wallingford, which is down near Oxford, and there's also sites in Scotland and Wales and in the north of England. But really this sort of one mission that they have on the website here gives an idea of what we do, to undertake research on terrestrial and freshwater ecosystems that underpins evidence-based decisions and innovation by policymakers. So, very much what we're doing, it's lots of discovery science, blue skies research, but really all with the aim of trying to provide information to policymakers. We do a lot of work. We are mainly government funded, so we do lots of work to try and help government agencies make decisions, but also helping a wide range of stakeholders, water companies, environmental management agencies, consultancies, and so on. So we do a real diversity of work that I've not got time to focus on today. I'm going to be focusing a bit on what we do with hydrological research. I'll get used to this in a moment. This is who's in my group. If you're wondering why this looks slightly like it's got a bit of a Christmas angle to it, I gave a presentation at Christmas time about my group, and so this is a slide I used at the time showing, like we have advent calendars in the UK, and this is just to show who's in our group. So much of what I'm talking about actually, just to give thanks to many of these people, the content of what I'm talking about is work from across this broad group of people. But what do we do in the Hydrological Status and Outlooks group? You may also notice a Christmas theme to this, because it's on the same presentation. We do with hydrology past, we deal with hydrology present, and hydrology yet to come, as famous from Charles Dickens' Christmas Carol. This is to really get across the main focus of what we do in my group, which is lots of work on long-term historical hydrology. So we manage the National River Flow Archive, which is actually the main hydrometric database for the UK. We manage that, so we take data from all the UK measuring agencies, we store that data, quality control it, and provide it to the public. We also do lots of work looking at trends, reconstruction, which is what I'll be talking a bit about today. We do a lot of our work is in the present, so that's really focusing on monitoring, trying to understand the current hydrological situation when there are big flood and drought events. And also we do lots of work looking at the future, so some of that is forecasting on the scale of seasonal forecasting, but also climate change, which I'm not going to cover today. Again, I tried to focus this talk more on the past and the present, and also a bit about forecasting, but we do also do lots of work looking at long-term adaptation to climate change. So that's what we do in the group. And I'd now like to just give a bit of context, because you're probably asking the question, well, why am I talking about drought when I'm from the UK, which, as you know, is a famously very wet country. But whilst it is a wet country, I'd like to draw your attention to this map here, which shows the rainfall amount, showing in Scotland and many parts of the north and west average rainfall values over 2,000 millimetres. Oh. But down here in the south and east, it's actually less than 600 millimetres is common. And in fact, if you think that, as you probably know, London is down here, large other urban centres, big concentrations of population industry and so on in many of the drier parts of the country, in the south and also along the east. And so there is this there's a lack of balance between water supply and demand, huge demands in many of the areas where rainfall is lowest. The other interesting thing is that some of our droughts, so we had a drought in 2010 to 12, quite recently, and one of the interesting things about that was its long duration. We have droughts that last a number of years in the UK. And also the 1976 drought, which is the iconic one, and you may be aware of that, was a big drought in other parts of Europe, and in the UK had huge economic and societal impacts. The common thing about these droughts, and also others in the 1990s, is that they resulted from quite a unique process where there's lots of groundwater in the south and east, and when that groundwater is good from a water supply point of view, it's 70% of the water supply in many of these areas. Groundwater reserves are good, but if you have dry winters, 2 dry winters in a row, say, the groundwater level drops in successive years. And so most of these really major droughts we've had have been as a result of multi-year occurrences of dry winters, which means that they tend to happen over a long period and take a long time to evolve, and crucially a long time to recover. So although we don't face the sort of hyper aridity situation you have in Spain, droughts are arguably less frequent in the UK, but when they occur, they can be very long-lasting, and in many of the areas in the south and east they can have huge economic impacts too. The other thing about drought in the UK, that the 2010 to 12 drought, it was the year of the Olympics, so there was a lot of concern in the spring of that we are hosting the Olympics that was going to have big impacts that summer. In the end, we had the wettest summer in 100 years, so that ended the drought spectacularly, and we had flooding. But the concern at that time really highlighted to everyone that drought is a serious issue. The other thing that people are very much aware of is these are some projections for the UK showing summer river flows. This is a kind of ensemble of climate change projections run through a hydrological model out to the 2050s. You don't need to pay too much attention other than the fact that many of these are yellow, red colours. So this is a decrease in summer flows is projected in the UK. So we expect under climate change to see a drying, lower river flows in the summer, especially more variability, so potentially more drier winters at certain times. So this climate change is expected, in short, climate change is expected to make droughts more severe in the UK. And at the same time, population is expected to increase. So you have this problem of supply and demand becomes more acute as you go into the future, which presents all sorts of challenges for water management. Having said that, we have a really well-evolved water management system in the UK. Water resource management plans and drought plans are actually, are required by law. We have private water companies, and they are obliged to produce drought plans and long-term plans over a 25-year timescale about their water resource management investments. Oh dear, can't quite get. I'm just in the wrong one.
Next one.
Keep just pressing the left-hand one, but I need training.
This one?
Yep, this one, yes. So for example, water companies. This is an example from a water company drought plan where they have their reservoir levels and they show the blue line as the it's touching the screen.
It is very sensitive.
So I can use that in the future. The blue line is the reservoir levels, and it shows that as the reservoir levels go down, they have triggers where they will take certain actions, which might be a public information campaign, a media campaign. It could be a ban on use of hose pipes for watering gardens, and then the measures become more severe until eventually they would be providing rationing of water. So they have these very detailed plans which are articulated in advance for water resource management. And the key challenge, of course, is making sure that there is adequate water for public water supply, whilst also providing enough water for wildlife and keeping the ecology of watercourses intact. And many of the recent droughts have actually had some quite notable pressures on ecology. So that's the challenges and the context, and I'd now like to, can I just move on there? Yeah, okay, so I'm going to talk about these 4 areas, drought indicators and monitoring, and then moving from indicators into impacts, a bit of seasonal forecasting, and then lastly something a little bit different but hopefully interesting around historical reconstruction. So, indicators and monitoring. In the UK, we at CEH have been doing operational water situation monitoring since 1988. This is a product called the Monthly Hydrological Summary, where every month from '88 until now, we release a report each month showing current status of rainfall, river flows, groundwater, and so on. That's very widely used in the UK, and we do this operationally. This is showing a map of groundwater levels during the 2010 to 12 drought, with all the orange colours showing really low levels. So there is already water sort of drought situation monitoring. However, at the moment, what it is, we produce a 12-page document. It's like a static PDF document that we produce each month, and there's lots of interest from stakeholders to try and they appreciate the information and the interpretation, but people want actual, more detailed, local scale information on drought status. The challenge, of course, you'll all be aware, I'm sure, if you've done any work at all on drought, that we can define drought in lots of different ways, and this is the classic example of all droughts start with a meteorological deficit, but then you have agricultural droughts, hydrological drought, and socio-economic drought, and so on. This is very well described in the literature. And so one of the things we've been doing in the UK is trying to actually work with people who use drought situation information to understand, what they want, how do they define drought, and what are they interested in monitoring. And we had a couple of stakeholder workshops that are just being written up at the moment over the last few years. There's lots of things came out of that, but one of the interesting things I wanted to draw your attention to is the types of droughts. People since the 80s, Don Wilhite's work, have recognised agricultural or hydrological drought, but our Scottish environmental managers were saying in Scotland we have effectively whisky droughts and salmon droughts. You can think of, there are certain unique combinations of hydrological characteristics that will impact certain sectors, so whisky supplies. In 2012 there was a really serious drought in Scotland that impacted whisky provision on the islands. Similarly, our Canal and Rivers Trust, they have a definition of navigational drought. So there are a whole load of different views of what drought, what is interesting in terms of drought characteristics for different stakeholders. One of the things we've been doing with our monitoring is trying to take that sort of thing on board. Just the other thing on the previous slide was there's this tension between different definitions and understanding of drought, but at the same time, our Environment Agency and the government especially want to have consistency across the whole board. And this ties in quite nicely with some work that we've been doing as part of one of our droughts projects, which is on drought indicators. These, the SPI, people may have heard of, is very widely used, recommended by the World Meteorological Organization. And you can create a time series which has got lots of desirable attributes. You can compare across space and time in a very robust and sort of fair way. In the UK, as I mentioned, we have an order of magnitude rainfall gradient, so these kind of standardised indicators allow you to make good regional comparisons. We've been working a lot with these. These are never really used in the UK in the same way that they've been used in many other countries for monitoring. This is something we've been trying to implement over the last few years. To provide the underpinning basis for this, because these, I'll just go back one, because these indicators have not been used so much in the UK, we did a lot of work. We published a couple of papers looking at the applicability of these indicators, which statistical distributions to use, looking at how the rainfall and precipitation droughts influence hydrology. And as a result, we have these indicators now for all aspects of the hydrological cycle. And users are interested in these sorts of indicators, but people want to get access to these indicators for drought monitoring. And one of the things that we've done in the UK is we've now released what we're calling the UK Drought Portal, which is a new web-based tool for drought monitoring. So in addition to our 12-page reports we produce each month, we're now also releasing these indicators, 5 kilometre resolution on a grid around the UK, Users can click on a catchment. This is actually the latest information. In Scotland, you can see it's been dry over the last 6 months. And users can click on a catchment or a grid cell and can then actually visualize a historical time series. So it allows people to actually access data rather than just reading about drought situation. They can actually explore the data on a 5 kilometre scale, which is a really big innovation, a big step forwards in UK drought monitoring. There's a couple of other things that are going on related to this. I just thought I'd mention, really. This is not just within my group, but across the whole of CEH. We're investing in this soil moisture network, a real-time soil moisture monitoring network based on these Cosmos UK, these Cosmos sensors. This is, by what witchcraft these work, I don't really know. It's an incredible bit of physics. It uses cosmic rays, the incidence of cosmic rays, to measure soil moisture over a large, sort of several hundred meters diameter area. So it's actually got a much bigger footprint than usual instruments. And this is brand new. The earliest of these went in 2013. There are now 50 of them around the country, and all of the data is provided real time. I just thought I'd mention this because the work I showed a moment ago, where we've got river flows, groundwater, and so on, all being put out onto a portal that people can access. This is another portal for soil moisture that potentially, what the idea is to bring all of this stuff into one single portal so that people can monitor all aspects of the hydrological cycle together. Similarly, we've been working a lot with Earth observation data. One of my colleagues, Maliko Tanguy, has been working on a European-wide data set based on various satellite products that produce Earth observation vegetation condition. We've also had a project more recently exploring how we can bring together Earth observation soil moisture, Earth observation vegetation, along with all of our existing river flow and rainfall indicators. This is just a demonstration. It's not an operational tool. It was based on 4 years worth of data, but it shows the idea behind what we're trying to achieve, which is a single portal that allows people to explore and interrogate spatial and temporal data from both all the in-situ river flows and groundwater and other information we host, as well as information from satellites that are clearly give more information, and also things that we can't monitor in situ, like vegetation health, and they also provide continuous spatial data. So this is a vision for where we'd like to go. There's lots of things we need to do to get there. But just to give an overview of what we're doing in terms of drought monitoring, I'd now like to take a step forwards to think about what this means for stakeholders and users, really. This is all part of this work I'm now talking about is part of a project called Driver, where it finished last year. We worked with colleagues in the US National Drought Mitigation Centre and CSIRO in Australia, and also colleagues in Europe from Germany. And the idea was to actually look at drought monitoring and early warning systems on these 3 continents, and to actually understand how drought monitoring and early warning is done, and crucially to look at some of the interdisciplinary questions around how you link drought monitoring information with impacts on society. So that was the basis of the Driver project, really. I'm not going to talk about all the international stuff because I don't have time. I'm going to focus on the UK. But this was a review paper that came out of Driver in the early part of the project. I say a review, we did a review, but we also did a survey of 40 different monitoring and early warning providers from all over the world to actually understand how they do their monitoring. And I'm not going to talk in detail about the review, just to say the title says it all, really. That what we argued there was that there's a need, really, to go beyond. These drought monitoring systems have lots of wonderfully coloured maps showing rainfall and vegetation health, but what does that actually mean in terms of impacts on society? That's the real fundamental question. And most of the systems that are out there, they don't really have that much information on the actual societal vulnerability and potential impacts. So that was the big idea behind Driver, linking on the one hand the nice colourful maps on drought monitoring systems with impacts on society, that missing link, effectively. And you can conceptualise what we were doing there. This is a really simple plot, but this is showing a regional coverage of the SPI, the Standardised Precipitation Index, and also showing, these grey bars are showing recorded impacts, and I'll come on to how that was done in a moment. But just to show that in a really nice, simple way, this is showing some sort of link between an indicator and an impact. So it's providing some verification, ground truth, if you like, for these indicators. It's all very well thinking that the SPI is a robust statistical indicator, but what does an SPI value of -2 or -1.5 mean for a farmer or a water manager? That's the whole sort of idea of providing some ground truth by linking those indicators, thresholds in the indicators through to impacts. Much of the work that was done in Driver used a drought impact inventory created for Europe, which was actually done as part of another project which preceded Driver. It's essentially a database of drought impacts collated across the whole of the European continent. It's based on secondary sources, so reports prepared after drought events or other information. There is a similar thing in the US, which is the drought impact report, but in the US it's more sophisticated. It's based on media scraping. They have a whole team whose job it is to do this kind of impact collation. There's nothing like that for Europe, so this project tried to assemble a database of impacts. It's not real time, it's looking at past impacts. As Sergio pointed out yesterday, there are lots of biases in the dataset, as you might expect. If you look at the dataset, it looks like there are more impacts of drought in the UK than there are in Spain, which is perhaps maybe debatable. It's got more to do with the fact that Lucy Barker from my team spent hours and hours and hours adding data in the UK one, whereas it's maybe not been done yet anywhere in Spain. But those biases aside, it provides a framework at least for adding impact information and crucially classifying it into a range of different types, like impacts on fires, water quality, ecosystems, and so on. So what we did within Driver, that previous project assembled the database, we added some more data to it, but then the idea in Driver was to link observational drought indicators through to impacts. And this is a paper that we collaborated with the Germans on in Hesse. It's a complicated plot. I don't intend to unpack it all completely, but it just shows these along the bottom. These are different types of drought indicators calculated over different durations. These here are regions in the UK that you can see on the map, and the coloured squares show where there are significant correlations between the indicator and an observational impact. That's the basic story. And the basic kind of key result really is what it shows in the UK is that there is a relationship between longer durations of the SPI and impacts in the south and east, and a shorter duration of SPI and impacts in the north and west. And that actually chimes with what we might expect, because in the south and east, where there's the groundwater, as I said, droughts tend to evolve very slowly, and it's only after several winters that you would actually have a problem in groundwater that would lead to impacts. In the north and west, there's no storage, so when you have a few dry months, you start to have problems with potential droughts and low reservoir levels. So this actually does show it's a promising start. But what I want to talk a bit more about now, with the theme I said from the start about working with decision makers, is what we've been doing in the UK is building on that. That was done at a core scale in the UK and Germany. The idea of what we're doing now is similarly working on this theme of linking indicators to impacts. I mentioned earlier on about our water companies, and they have these triggers that they use. So this is a reservoir in Anglian, and this shows the various trigger levels that they use for the reservoir. What we're doing now, and this is after Driver, it's part of a current project that we're working on where we're translating much of this previous drought research into stakeholder-friendly outputs, is we're linking, this is the water company's reservoir levels, and these triggers are shown in a slightly different way here. What this is down the bottom is the SPI and the standardised streamflow index for the catchment upstream of the reservoir. So what we're doing effectively is translating the SPI and the SPEI, so all the data that we release on our monthly drought portal that goes out that people can use, which we're mapping it onto the water company drought plan. So that effectively what we're doing, to cut a long story short, is we're using translating the science outputs on the drought portal into the language that the water companies use, so that they can actually use this kind of chain from linking these indicators that they would be able to access on the portal with their own drought plans. Another example that we're doing working on agriculture is again linking indicators, so linking our vegetation condition indices and linking those to the SPI around the country, and showing the red here showing some quite promising relationships in the south and east between the SPI and vegetation health. So in many of the more agricultural areas there is actually some reasonable linkage between the indicators we have on the drought portal and vegetation health, which is measured via the remote sensing. So it's kind of not real impacts information, but it's an analogue of impacts. What we're now doing is working with the National Farmers Union and other organisations based around agriculture to try and get more detailed agricultural impacts information. I know in Spain I've seen you have great databases of crop yields and all sorts of other information, and there's not really a readily accessible equivalent in the UK, so we're working with agricultural stakeholders to try and fill that gap now. And the final one I wanted to draw attention to is where we're, the ecology is really one of the key things in the UK. The water companies have a responsibility to measure, to keep security of water supply, but they also have to have favourable conditions for wildlife. And our Environment Agency are the regulators who make sure that that happens in effect. And the Environment Agency, they do lots of routine monitoring of ecosystem health. Macroinvertebrates and various other things are monitored routinely. And they've tried to just set up what they're calling a national drought surveillance network, where for a number of key sites around the country, they're trying to look at their routine monitoring during drought episodes and doing it more frequently and trying to see whether or not they can actually track the status of ecosystem health as episodes emerge. And what we've been doing with them is linking our drought indicators, so this is the standardised stream flow index, and trying to link it to their ecological metrics effectively. What you see is a bit of a mess, to be quite frank. It's I guess I'm showing this because it's getting the point across that once you start dealing, although we like to think that we can link these indicators through to observational impacts on society and ecosystems, when you're dealing with ecosystems especially, then things are obviously really complicated. There are relationships that are being exploited around the country, but it is really complicated. There's no straightforward relationship between flow and necessarily ecosystem health. So, okay. So that's what we're trying to do in terms of decision making. I'm going to, for the next 10 minutes, I'm going to focus a bit on seasonal forecasting and then quite quickly the historical droughts stuff. So what we're doing within forecasting, in the UK we do have, within CEH we produce an operational hydrological outlook, which was launched in 2013. It's a collaboration with a number of organisations, our meteorological office, British Geological Survey, and all of the environmental regulators themselves. And it's essentially, I've not got lots of time to go into the methods or the science behind this, so I'm not going to talk in detail about that. There's a paper that came out last year where we've synthesised all of the different methodologies, and you can find out much more about this hydrological outlook in that paper. Crucially though, the big idea behind this outlook, it's based on a number of different methods. That's probably the main point I wanted to get across. We have 3 key methods for river flows, and there are similar things for groundwater that I'm not going to go into today. But we have essentially one method where we use precipitation forecasts. So our Met Office every month produce operational seasonal forecasts from their climate models, the Glossy 5 system, and they produce those precipitation forecasts. And what we do here in the Outlook is we run those through hydrological models. It's a 1 kilometre gridded model for the UK, and this is an example. I'll talk about the outputs in a moment. Another method we use doesn't use any precipitation forecast. Actually, I'll skip over to this one at the end. It doesn't use precipitation forecasts. It actually uses the entire historical ensemble of data, of precipitation data to drive a model. In a sense, what you can think of here is that if you've got a 50-year record, you use all 50 years of historical data and you run them through the model. So if you're in, let's say we're in June now, you take all 50 Junes and you run those through the model, and it gives you an ensemble of what might happen next. And then there's also another version which is based on essentially just using historical patterns. effectively looking at stream flows that are similar to the current time in the historical record and finding analogues to see what might happen next. All of these have been published and all of these have been verified. As I say, I don't want to go into lots of detail. What I do want to just get across is that the nice thing about having a multi-method system is that different methods do well at different times. This method here, based on the historical ensembles, it actually does a good job in the south and east. That's because there's lots of groundwater, so there's lots of memory in the system. It does a good job in the south and east, whereas in the north and west it's so variable that just wouldn't work. But the method using the forecasts from the Met Office in the north and west, there is actually some skill, but only for winter, because we're starting to get to the stage where the Met Office can forecast the North Atlantic Oscillation fairly well. So there is scope in winter when the NAO is very important. There is some skill. And this other method as well, the historical method, works well in the south and east. But if you bring all of those things together, then you've got a system that can actually provide some useful information all the way through the year. I say some, the skill is still low. We live on an island on the edge of the Atlantic Ocean. There's lots of variability in our climate. And this is the kind of thing we produce each month operationally. So we meet each month, we look at all the model outputs, and we try and come up with, this is a bit like the sort of thing you'd get in a weather forecast, just quite in trying to put lines and blobs on the map to show broadly how these methods agree or not agree, and this is the sort of headline message for policymakers, really. And we also then provide, each month we produce all the modelling outputs. So this is the modelling outputs from the ensemble streamflow method, and this is one of the outputs from the historical analogues method, and all of this stuff is packaged up every month so people can access the outputs. But what I really wanted to talk about today was, is this useful? Certainly, this has been going for a few years, and the outlook was used in a flooding context. We had some really major floods in the UK recently. My presentation's about drought, but in the last 5 or 6 years, the focus has been more on floods because we've had 2 of the biggest flooding events in decades. And the outlook has been used quite extensively in that. So these are some outputs from the Environment Agency that actually use our outlook forecast within them. There was, in the drought episode last year, the developing drought, we've had lots of feedback from the regulators and the water companies that the outlook was useful to them. But the general feedback is it's useful context as part of a range of information. If you ask them the question, would you use the outlook to make a big money decision, then it's a slightly different story, because these are ensemble outputs, there's big uncertainties in them. It was just to say as well, the outlook has been quite visible for the media, which is good. It's informed quite a lot of stories about flooding and drought in the media, which is good. But yeah, would stakeholders use it to make a big money decision? The answer is probably not yet. But the UK is not alone. This is a paper from 2005, Weather Forecasts Are for Wimps. Why water resource managers do not use climate forecasts. There is this intrinsic barrier to uptake of seasonal forecasting information, because water resource managers, they are very averse to, well, they will use the historical data because that's observed and it's actually happened and they've managed their systems in the past. That's useful, whereas forecasts are inherently uncertain. We're dealing with potentially, as I say, big money decisions. There's lots of fallout, regulatory fallout if they get things wrong. So there are barriers to uptake. But what I wanted to finish on this topic, on the theme of what I've been talking about around stakeholders, is we're now currently involved in a project called Endows, which is part of the droughts programme that Sergio mentions, where we're working with water companies, farmers and environmental managers closely to actually demonstrate the value of these forecast outputs. So we're trying to work with them to actually co-design case studies. So for example, Anglian Water, one of the water companies, we've got catchments in Anglian region where we've got all of our historical timecast information, and we're working with the company to see if they'd had that information during the drought of 2010 to 12, how would that have changed the decisions that they made. So it's kind of hypothetical case study outputs, but all with the aim of trying to actually make these forecasts more usable. Because although there are barriers to forecast uptake, what people don't, many of those barriers are based on the state of forecasting 10 years ago when there was no skill at all. Whereas now there is more skill, even though it's uncertain, there is more skill to use. So we're trying to effectively overcome those barriers and make sure people are aware that even though it's still risky and that it's still uncertain, it always will be, things are much better now and there is usable information in these forecasts. Just 5 minutes left based on the time I was planning to talk, so we'll try and go through this quite quickly just to give an overview really. The last bit of the talk that I wanted to cover is something a bit different. Much of what I've talked about so far is around drought monitoring, early warning and forecasting with the aim of working to what we're trying to do for stakeholders is help them out when they're in a drought. So if you're in a drought and things are emerging, what information can you use to help make decisions based on monitoring and forecasting information? This is slightly different. This is historical reconstruction with a different aim. The question is, why do you want to reconstruct droughts? Well, again, I mentioned earlier on, this is the thing I've already mentioned a few times. Water companies have these drought plans. This is another one. This is a reservoir in the east of England where they're showing the drought plans, what they'll do at various different stages. To actually get this information and to prepare their long-term water resource management plans, they need to understand historical drought occurrence. So this is an example here. It's a rare example for this catchment from a paper that I was involved in a few years ago, where there's a long record of rainfall droughts going back to 1803 that has been used to actually test that drought plan. So they've taken historical droughts, built scenarios and run it through the drought plan. But this is an unusual occurrence. Normally, water companies are dealing with much shorter records when they're doing their long-term planning. This is why. In the UK, these are graphs showing the growth of our hydrometric networks. I was talking to you, Sergio, about this the other day. Our streamflow network in the 1960s, it goes from less than 200 up to 1,000 gauges. So from the 60s onwards, we have lots of gauges in the UK for river flows, similarly for groundwater. But once you go back before the 1960s, the number is very low. For rainfall as well, in 1960, there is a huge amount of rain gauges. There's a cliff here. That's because many of the early rainfall records have not been digitised. So, the big idea behind this drought reconstruction project is to improve our understanding of past drought occurrence in the UK. There's a number of stages. The Met Office have been digitising data. So they've been taking their many records that they have on paper, adding them to their national product. And here's an example of a before and after. This is August 1891, showing the much cruder rainfall, spatial rainfall representation before compared to what they've got now. They've done the gridding. And this is what we've been doing, is applying drought indicators all the way back to the 1860s based on these newly recovered data. So this is a big effort, a huge effort actually, to improve particularly the focus really has been on the period from the late 1800s through to about 1910 or 1920, because there's a number of big drought events in that period. So, and obviously this early period was really sparse, and they're now filling that in for this project. Another thing we've been doing is looking at potential of evapotranspiration. I've not got time to go into this in detail, but a paper's just come out on this. You don't have all of the variables you need to properly estimate PE, going back to 1890, so you need to use temperature. There's lots of different methods out there, and what Maliko, my colleague, has done is tested in a very robust way all of the different approaches to estimating PE. These wheels are from the paper, and they show all the different permutations of ways you could estimate PE. And what the output of this is a 5-kilometre gridded daily PE product going all the way back to 1891 for the whole of the UK. Once you've got your rainfall and you've got your PE, you can start to estimate stream flows, and this is what we're really focusing on. Our colleagues in the groundwater, in the geological survey, are also doing the same for groundwater. But for stream flow, we've essentially set up hydrological models at 300 catchments across the UK. We've taken the rainfall and PE I mentioned a moment ago, and we've used that to drive these models all the way back to the 1890s. Katie Smith's leading this work and is about to submit a paper on this. Actually, again, it's uncertain, but she's got quite sophisticated framework for actually trying to understand that uncertainty, and the models generally, based on calibration and verification on this data set, they actually do a really good job of estimating river flows. So as a result, we're able to go from our short records all the way back to 1890, and this shows in a headline message, if you like, why what we've done is useful. So this is 1890 to 2015. This is for a set of about 150 catchments just arranged from north to south. And what it is, the red bits show drought episodes and the blue bits show wet episodes. That's all you need to know. And as you can see, most of the records this is based on observational data. Most of the records start in the 1960s, and we've got a handful of sites going back to the 1930s. That's what our observational record is. This is the new picture based on the reconstructed data. So, you know, we were essentially, without the reconstructions, we were missing major hydrological droughts in the 1940s, in the 1930s, the 1920s, and the turn of the 20th century. People knew about these droughts because we do have some rainfall records, but we never had anything like the spatial and temporal coverage of historical droughts that we do have now. Lucy Barker, one of my colleagues, is working on the paper on the outputs of that modelling for Hess at the moment, and what she's doing is extracting the drought events from the streamflow records, looking at their duration, their severity, ranking the droughts according to their severity, and then mapping that and plotting it up for the UK. What you can do though is that the paper is still in progress, but she's actually delivered this an app. It's essentially a website where you can go on, and for any one of the catchments, for any one of the years, you can look at the historical drought time series. So it's a really, really nice tool that she's developed. And the whole point of this, and this is what my last slide really, the whole point of this is that we're opening up this data set for everyone to use. So you know, our interest was to produce some papers looking at the relative severity of historical droughts. But the idea of opening the data sets up, anyone can download them, anyone can explore the data using that app. The idea is that, so as I mentioned a moment ago, water companies test their systems. This is another example of some work that we're involved in, testing a couple of different reservoir systems for their resilience. Much of that is based on short records, and what we're doing now is working with the water companies to use these new, longer records and seeing how their assessments of their resilience, their stress tests of their water supply systems, to see how they're improved using the new historical data. So I think that's pretty much what I wanted to convey, and I'd like to summarise that by a few high-level points, which is that yes, we don't have droughts like you have droughts in Spain, but when they do occur, they can be really long-lasting and have really serious impacts, and they're projected to get worse. As a result, there's been a big interest in drought over the last 5 or 6 years scientifically. Even if the public debate has moved towards flooding, there's lots of science going on as a result of these new droughts projects. CEH's work, I've presented a selection really on indicators, monitoring, forecasting and historical reconstruction. And it's all newly available work that's actually providing much more data and methods for people to understand drought. Crucially, with the theme of my talk, all of that is being co-developed with stakeholders. So the idea is that we're engaging stakeholders early on, understanding what their needs are around drought planning, water resource management planning, and then now, with this work we're doing at the moment that I've tried to illustrate with a few examples, we're working closely bilaterally with those stakeholders to understand, to work on case studies for how, you know, showing if they use these new data, what the impacts would be. So, I'd like to just end there, and thank you very much for your attention. I hope it's given a sort of overview of many of the things that we're doing in relation to drought, and I'll be very happy to, first of all, very happy to take any questions, but also very happy to follow up any further interest afterwards. So you can always get in touch with me on this email address. Thank you. Cheers.